Have you ever just, thought about what would happen if you kept adding things up forever? I mean, it seems obvious, right? The answer should just get bigger and bigger, shooting off towards infinity. But what if I told you that sometimes you can add up an infinite number of things and get a perfectly normal, finite number? Well, today, we're going to see exactly how that works.
So yeah, that's the big question, isn't it? It feels like a paradox, something that just shouldn't be possible. How can an endless process of adding just stop at a specific number? It sounds like a riddle, but the answer isn't buried in some super complex math. Actually, the answer is beautiful, it's visual, and we're going to use a few simple shapes to make sense of it all. All right, let's kick things off with a real classic. We're going to take a nice simple square and basically play a game of cutting it in half, over and over and over again. Let's see where that takes us.
Okay, so here's our first sequence. It's what mathematicians call a geometric series. We start with 1/2. Then we add a quarter. Then an eighth, a 16th, and you get the idea. Each new piece we add is exactly half the size of the piece before it. And we're going to do this forever. So, any bets on what the final answer will be?
So imagine we have this square, and let's just say its total area is exactly 1. For our first move, we're just going to shade in half of it. Simple enough, right? So the shaded area we have so far represents the very first number in our series, 1/2. Okay, for our next step, we look at the empty white space that's left over. We're going to shade in exactly half of that. And since we started with half, well, half of the remaining half is a quarter of the whole square. So boom, we've just added 1/4 to our total. And we just keep going. We take what's left and shade half of it. That's an eighth. Then half of what's left after that, a 16th. As you can see, this process can go on forever, and there will technically always be a tiny little sliver of white left. But that sliver is getting infinitely smaller. It's approaching 0. The shaded part is getting closer and closer to swallowing up the whole square.
So what does this picture tell us? It means if you add 1/2 plus 1/4 plus 1/8 plus 1/16, and you keep going forever and ever, you don't get infinity. You get exactly 1, the total area of that square we started with. Pretty cool, right?
Okay, that was a pretty satisfying answer. But what happens if we start with a different fraction? Let's switch things up and try another one, this time using a triangle. And I have a feeling the answer here is not going to be what you expect.
So this time, our series is all about thirds. We've got 1/3 plus 1/9 plus 1/27, and on and on. Each piece is 1/3 the size of the one before it. We're going to use the same visual trick to see what happens when we add all these up.
Let's start with a big triangle. Now, if you find the exact center point and draw lines out to each of the 3 corners, you'll see it splits the whole thing into 3 smaller, identical triangles. So for our first term, we'll just shade one of those. That's 1/3 of the total area.
Now look at how the next pieces start to fit in. The next little shaded triangle is 1/3 the size of our first one, which makes it 1/9 of the total. Then we add another one that's a third of that. You can see how these colored pieces just keep getting smaller and smaller, perfectly filling up the space and creeping towards that center line of the big triangle.
So what happens when we let this go on forever? All those little shaded pieces will eventually fill up the entire left half of our original triangle. Perfectly. Which means that 1/3 plus 1/9 plus 1/27 all the way out to infinity adds up to 1/2. Kind of weird, right? Okay, let's do one more. This one's my favorite because it creates this absolutely beautiful pattern that's almost like a fractal, where you see the same shape repeating itself on smaller and smaller scales.
All right, our last series for today, 1/4 plus 1/16 plus 1/64, and so on. Now, you might be starting to sense a pattern in these answers. Let's see if this last picture proves our hunch. So check out this visual. We start with a big square, and that first blue square takes up exactly 1/4 of it. The next blue square is a quarter of the size of the first one, which makes it a 16th of the whole thing. And this pattern just keeps going, spiraling inward forever. All those blue squares put together, that's our infinite sum. So what's the total area of all the blue squares combined? Well, if you could follow that spiral to infinity, you would find that it adds up to exactly 1/3 of the entire large square. So our infinite sum here is 1/3. Okay, so let's recap. We've looked at 3 different infinite series, and every single one added up to a nice, simple fraction. Let's put them all side by side and see if we can finally crack the code. Okay, look at this. When our series started with 1/2, the sum was 1. When it started with 1/3, the sum was 1/2. And when we started with 1/4, the sum was 1/3.
Are you seeing it? The denominator of the answer is always just one less than the denominator of the very first number in the series. It's so clean, it's elegant.
This amazing pattern actually leads us to a really simple but incredibly powerful rule. For any series that looks like the ones we've seen today, where r is that bottom number in the first fraction, the sum will always be 1 divided by r minus 1. This one little formula explains everything we just saw.
And for anyone who wants to see the little bit of algebra, the magic trick behind the curtain, here's how it works. First, let's just call our whole infinite sum s. Now, for step 2, watch this. If we multiply that entire sum by r, what we end up with is something that looks very familiar. It's just 1 plus our original sum s. That gives us this tiny equation, rs equals 1 plus s. Do a little bit of rearranging, and we solve for s. And what do we get? Exactly 1 over r minus 1. The math proves what our pictures were telling us all along.
Now, the algebra is definitely a neat trick, but come on, there's just something so satisfying about seeing these infinite sums get trapped inside a simple shape, right there on the screen.
And really, that's the whole point. We can prove these things with equations, sure, but seeing them visually gives you a much deeper gut feeling for how it all works. It takes this really abstract, kind of mind-bending idea about infinity and turns it into something you can actually point to and understand.
It really makes you wonder, doesn't it? What other mathematical secrets are just hiding out there, right in front of us, waiting for us to find a new way to look at them? So, keep your eyes open. You never know what beautiful, infinite patterns you might stumble upon next.